Now, what kind of walls do we want to have? What kind of insulation value do we want to have? We're going to go on from here. Well, what is my low end option, let's call it? If we're going to take and put it on a joist floor here, my low end option would what they call a strap wall. Now, a strap wall is a 2x6 wall, 2x6 bottom plate, and a 2x6 goes up, and you have your 2x6 top plates, and you have your roof truss system that goes on top of that. Well, 2x6s are okay, but you got a lot of conductivity, every stud, all the top plates, you have conductivity, heat loss from that. The studs themselves are not very good heat. So now what can we do? We can put 2x2s on the walls to make that stud cavity deeper and get more insulation and also break conductivity, called the strap wall construction. Now we can put the straps on the inside or we can put the straps on the outside if you're going to do board on board type construction. You can also put it on the outside and put plywood sheathing and do whatever you want on that. And later we'll go into more details about how to create a good wall that will have a good drain plane and have no issues with it. Again, one of the no issues is big overhang, 3 feet or more, depending upon where it's located on the house. But a connection to this is a strap wall. This is my minimum. This is my minimum. So I know that I have 5.5 inches and 1.5 inches, or maybe 1.5 inches on both sides. So now I've got a 7-inch wall or an 8.5-inch wall. Now we're starting to get up into an R30-ish wall with this strap wall. And we break conductivity. But we're doing a 2x6 with straps. 2x6 are, got to take a big species tree down to do that. And we're getting an R30, and we're taking up somewhere between 7 and 8 inches. Okay, that's a decent wall, my minimum. So now what's another way to go on top of this? Well, we can go a double wall. So we can go a 2x4 plate, much smaller species tree to be able to put up on there. We're going to have our 2x4 come up. I like doing a 2x4 advanced frame where we do just a single top plate rather than a double top plate. And what that means is we have to point load any truss or any joists right above the stud so it lines up. Now, a 2x4 wall, that's not a lot of insulation. You're right, I don't like a single 2x4 wall. I go for a double 2x4 wall. Why do I draw this one later? Because we can frame this whole thing up. We can get the roof on it with just a single 2x4 wall. Now we can come in and we can actually put our sheetrock on our ceiling, and we can put our second wall up inside of that. Now we have no conductivity. These do not touch at all. We spread that out so that we do 12 inches of insulation, winds up giving us an R45-ish, depending upon what insulation you're using and what type. Now, Massachusetts had a competition 5 years ago. This article was in Solar Today. And they put it out to find a low income, zero energy house. How are we going to create a house that is low energy and low cost? Well, they looked at 2x6 with foam, they looked at strap wall, they looked at double wall, they even looked at straw bale, a couple of the contractors did. And in the end, they looked at less insulation, more renewables. In the end, what won? A double wall cellulose wound up being the top 3 people that did it. A less conductivity, totally recycled, a blown cellulose. You can do a wet blown or dense pack in these walls, and that's where it depends on the R value, what you're getting out of that. You can take and do that, and then use less renewables, and they won as far as efficiency versus cost every time. Now, I don't think in the article that I read that they gave straw bale an honest chance. One of the reasons they don't give straw bale an honest chance is because there's not a lot of people that have done it, and the people that have done it haven't come up with a productive way of actually putting it together and make it. So we can go back here to that single 2x4 structure, advanced framing with our truss or our floor above it. And we can actually take and then come in and put a 2x2 in here and put foam here. And we can start to stack our bales on here and do a straw bale wall. What that is then we notch those bales 3.5 inches so they slide over. So now our bales are flush with this outside surface. Now we can mount all our doors and our windows on this outside surface, plaster over that, and we've got a really nice building that uses a lot less lumber. You look at that 2x6 wall, we were 2x6s with strap. You're looking at the double 2x4, we were doing two 2x4 walls. And again, you look at that, the strap wall, 7 inches. What are two 2x4s? 7 inches. We're using the same amount of material as we do in a strap wall in a double wall, and that gives us an R45 rather than R30. Now here we're getting an R40, R45 again with the straw bale, and instead of an inside wall, we're using one single 2x4 wall. And if we do advanced framing, we are talking about using less lumber, less fasteners, less nails, less labor to put the wall together, and then we can put the straw bale on it. Straw bale is not for everyone. I like it. I don't have it here. This is an earth berm home. It's not appropriate. We've done some earth berm homes that are partially earth bermed and partially open, and we've done straw in there. We've done an earth bermed home with a second story, a 12-12 pitch kind of thing, and did straw bale in there. So there's combinations most of the time. How do we get this mass? How do we get the insulation? And what is our interest? Is our interest doing straw bale, an annually renewable crop that's probably growing out in front of almost everybody's house, and we can use it and put it in a building that's going to be around for hundreds of years with 1 year's worth of growth? Or are we going to take and do a bunch of trees and lumber which create that long-term growth? What is a tree to cut it down? A pine is probably the quickest growing that we can use for this. Spruce tree, before you can cut it down and do anything, it's got to be a 30, 40, 50-year-old tree. We got 30 or 40 or 50 years into that. How are we going to get around that? Is that of interest to you to be more light on the planet and Earth? So again, the other thing that I always push is I call myself the square footage thief. So if anybody ever wants me to do, we're going to probably talk a lot about how we're going to get it down to that 1,000, 1,500, 500, 600 square foot, depending upon what you're looking to use that building for.